Hey guys, it's Ms. Capola. We are on day 8.1, investigating shape using calculus. Some of this is going to be review. Feel free to pause at any time and work through these at your own pace should you need to. All right, so we're going to hop back on the calculus train. And what we're going to do is we're going to use calculus to help us analyze graphs. So let's just draw ourselves a little graph here. I will do this, and I'll put them down here. Okay. So we talked about the fact that maximums and minimums or horizontal tangent lines happen at the maximums or minimums. And I'm going to write relative. So at a relative max or a relative min, we have a horizontal tangent line, and you can write that. I'm not going to, but we know when we have a horizontal tangent line that our derivative is equal to 0. Another word that IB likes to use for relative max and relative mins are turning points. And that should make sense, right? Because you're going from going uphill to downhill or vice versa. All right. So again, turning points happen when the derivative is, I didn't write that right. The derivative is equal to 0. All right. I'd like to bring up just a quick note and watch out for this, that you can have your derivative equal to 0, but not have a max or a min. And that's going to happen at a solid, a stationary inflection point. So that's what that is. And so notice my derivative is equal to 0 here, but I do not have a turning point. So you got to watch out for those. Last but not least, I just want to label this graph on the left. So we will label these two guys. Oops, arrow's going the wrong way. These are our relative maximums, all right, because they're going from increasing to decreasing. That's how you get a relative. This one here is actually extra special because he's also our absolute maximum. This guy creeping down here is a relative minimum. And our absolute minimum ends here because that's the lowest point you could get. Notice how I'm not saying he's a relative, because to get that relative, you need to go from increasing to decreasing or vice versa. All right. And then unfortunately, this guy really isn't anything except for he's just a plain endpoint. He's not a relative, and he's definitely not an absolute min. All right, so now that we've got that vocab out of the way, we're just going to go quickly through a quick review, and then we'll hop on to bigger and better things. And I'm going to select a fun color, which is pink. How predictable. You know what? I'm going to pick teal. Is teal in here? There she is. All right, so let's give you this little guy. Let's do y equals x to the 4th minus 4x to the 3rd plus 4x squared. Okay, and so what I want from him are going to be the intervals of increasing, decreasing, max, and min. So I'm just going to model for you what I would expect to see when you're given this guy. All right, so the first thing we need to do is we need to take the derivative. So the derivative is, let's see here, 4x cubed minus 12x squared plus 8x, and hopefully I didn't mess anything up. Okay, so again, we're looking for intervals of increasing, decreasing, max, and mins. So the first place we're going to start, guys, is by looking for our max and mins. And our max and mins are going to happen when the derivative is equal to 0. When you're setting the derivative equal to 0, you're looking for something called an inflection, or no, not an inflection point. You're looking for critical points. So critical points happen where your derivative is equal to 0, or where your derivative is undefined. More frequently, you'll hear about critical points in Calc 1, BC Calc, but it's important that you know a critical point is where your derivative is equal to 0 or where your derivative is undefined. So anyway, that's what I'm doing, okay? It's critical because it will give us a chance to either be a maximum or a minimum. So you could just see I'm factoring, wait a second. This should be cubed. I'm factoring out an x. Hopefully I'm doing it correctly. And a 4. And now I shall factor x squared minus 3x plus 2. So that's x minus 2 times x minus 1. All right. So that means I have 3 critical points. These critical points are at x equals 0, x equals 2, and x equals 1. Where did I pull these from, right? I just set each factor equal to 0. It's good practice to show that, okay? So these are possible maxes and mins. They don't have to be because they could be that stationary inflection point, but they're possible, okay? And so now you can remember the way that we would do this is we would make kind of like a little sign chart here, okay? So it is important that you stay organized. So these three little friends are going straight on my sign chart. So I'm going to put 0, I'm going to go in order, then I've got to do 1, then I've got to do 2, okay? And so what I'm looking at, guys, is I'm looking at signs of the derivative, because the sign of the derivative will tell me stuff about the original function, right? And we've talked about if the slope is positive, if my derivative is positive, my function's increasing. If my slope is negative, my derivative is negative and my function's decreasing. So these are all important things. All right. So what we now have to do is, well, we know that this is where the derivative is equal to 0. So I'll put my little zeros here. And we've got to do some test values. The test values I'm going to pick are -1, I'm going to pick 1/2, and I'm going to pick 3, okay? Oh, shoot, and I have to pick 1.5 too. Oh, now I just wrote a decimal and a fraction. All right. So what you're doing, guys, is you're testing the sign of the derivative. And notice how my calculator is not out right now. So here's the derivative, here's the derivative, here's the derivative, here's the derivative. The easiest place to test the sign of the derivative is if it's in factored form, okay? Because all you're doing is multiplying values. I only need the sign, S-I-G-N. So if you think about this, okay, I've got 4 times -1. That's a negative number. It's negative, all right? Then -1 minus 2. It's a negative number. Then -1 minus 1. That's a negative number. So a negative times a negative times a negative gives me a negative. That means my original function is decreasing. Okay. Now if I sub in positive 1/2, which is between 0 and 1, 4 times 1/2 is a positive, 1/2 minus 2, it's a negative, and 1/2 minus 1 is also a negative. Positive times 2 negatives gives me a positive, which means my function is increasing between 0 and 1. All right, so 1.5, positive, negative, positive. So this will give me a negative. And then again, I'm going to sub in 3, and you guys should be able to tell that when I sub 3 into each of these pieces, they're all going to be positive. So that means it's increasing again. So conveniently, this one minus, plus, with the signs rotating, that won't happen every single time. All right. So if I need to talk about intervals of decreasing, I can. Make sure you're talking about the x intervals. And again, we're talking about f of x. So f of x is decreasing between -infinity and 0 and 1 to 2. If I had to write the intervals of increasing, well, I'll just do it. That's going from 0 to 1 and 2 to infinity. All right, last but not least, you guys have to decide where are your relative maximums hitting and where are your relative minimums happening. And these are points, coordinates of points. So think about this, all right? You've got your little graph decreasing until 0. Then your graph is increasing again until 1. Then he's decreasing until 2. And then he's increasing again. Okay, this looks like a 4th degree polynomial to me because my tails are going the same way, which means he's even. Okay, and that makes sense because look at the original. He is a 4th degree. So these two should match up, like the shape. This is a 4th degree polynomial. My drawing, based on what my derivative said, looks like a 4th degree. Okay, so my relative max is at 1 comma something. My relative min is happening at 0 comma something and 2 comma something, okay? So sometimes they'll want the values, okay? So to get the y values, you have to sub your x's into the original. Some people sub it into the derivative and then they're shocked when they get 0. Well, the way we got these answers, guys, is by setting the derivative equal to 0. So it should make sense. If you're trying to describe f of x, you got to sub back into f of x. So hopefully that thought process makes sense to you guys there. Of course, I can work through these guys should we need the y values, but to save time, if it's okay with you, can we move on? All right. So let's look at this next piece for notes. Okay. What do we got here? All right. So let's do this guy. Ready? So y equals x cubed times x minus 4. And I want us to do the same thing. I want to get intervals of increasing, decreasing, max, and mins. So before we do that, to take the derivative of this, you'd have to use the product rule. I just suggest distributing it in. You can because there's no exponent here. If there were like a 2 up there, you'd have to use the product rule, but we don't have to because it's to the power of 1. So I just distributed it in. Okay. Next, I've got to take the derivative, dy dx. So that's 4x cubed minus 12x squared. After we take the derivative, we're setting it equal to 0. So I factored out a 4, and so I'm left with 2 values for x when I set this equal to 0, right? So these are my critical points. Hopefully I factored this correctly. So I've got critical points at 0 and 3. So those would be the guys that I would throw on the sign chart to try to find my turning points. So we've got f prime of x, we got to talk about his signs, and then we got to talk about what the original is doing, or in this case, y, or dy dx and y, right? So on here is going 0 and 3. And the reason I bring this guy up, okay, so when I'm doing my test values, I'm going to select -1, I'll select 1, and I'll select 4. I'm subbing it into my derivative. And what you'll notice here is that no matter what number I sub in here, this will always be positive. So that's important to note, that the first number here is always going to be positive because 4 times something squared will always give me a positive. Now, I'm subbing in -1. -1 minus 3, that's a negative number. 1 minus 3 is a negative number. 4 minus 3 is a positive number. Okay, so a positive times a negative is a negative, which means I've got decreasing. Again, I've got another decreasing here, and then here I've got an increasing. So you might be saying, well, what does f of x look like, or what does this original function look like when we draw him? Well, think about it. You're decreasing until you get to x is 0, and then it's saying you have to have a horizontal tangent line. But instead of going up, you got to continue to decrease until you get to x is 3. And then you can increase again. Okay? So unfortunately, 0 is a stationary inflection point, or you could just call it a point of inflection, that's fine. And then I don't really have any relative maximums, but I do have a relative minimum on my original graph at x is equal to 3. If I had to get the y value, or sometimes they'll say get the minimum value, then I would have to sub 3 into the original. So that would be 3 cubed times 3 minus 1. 3 cubed is 27. Oops, not 1. Excuse me, 4. 27 times -1. So the lowest point on my graph is going to be at x equals 3, and the minimum value is -27. All right, so that's pretty much the basics of increasing and decreasing. The next thing we will talk about is some creepy stuff you can do.